Hey, this is Steven from Legit Tech Tutorials, so welcome back to my product development series. We are back working on the plasma table. This is video number I believe this is video number 7. So this is video number 7 of our plasma cutter table. And yeah, so let's go ahead and get started. So we were working on the main assembly, and we got that guy all laid out with our carriage. So now we have the this is the Y carriage. So yeah, I need to rotate this so it's set up correctly. Let me see if I can rotate. Can I rotate the whole thing? No. We can rotate it later, but anyways, do kind of want it like this, so it's working correctly. Okay, so well, this is X, Y, Z, X, Y, Z. So we have the X done. So now we need to add a Y carriage, and basically what we're going to do with that is we're going to go plasma table, go to the bottom. Then we're going to take the carriage bracket and we're going to modify it so it uses. I don't know if you guys remember, but I was talking about where it has the bar, where it has like a square plate, right? The flat plate, and then the V bearings right on the side of the flat plate. So basically the size of the plate is going to be dictated by the size that we get the groove bearings to be. So basically this guy's going to fit back up on there, just kind of like the sub-assembly here was. Actually, now that I think about it, probably just modify it. The sub-assembly is kind of what we want here. We just want to edit this and save as, and then this is a sub-assembly, and then this is for the X, Y. So this is the Y sub-assembly. Carriage Y sub-assembly. And basically we're going to pick a side. Obviously it has to be the side that is not where the motor's coming through. So it's obviously going to be this side. Actually, now that I think about it, we can't modify this because this one's already edited. So we actually do have to come back here to the carriage bracket, go back to the master, and we're going to file save as carriage bracket Y. Create a new carriage bracket. This is carriage bracket Y. And then we're picking the opposite side of the motor. So the motor is going to go on this side. And then on this side is where we're going to have our Z attached. So we're going to draw a sketch on this side. And we're going to rotate so we can see. And then we're going to find the center. And find the center. And then we're going to set up some holes. We're just going to have a few holes here, maybe just 2 towards the edges. I'm going to say here maybe 1.25 there, and then 1.25 here. And then I'm going to have these both being construction lines. And then I'm going to put 2 points. 1 point there, 1 point there. And then I'm going to go ahead and stop sketch. I'm going to drill some holes. Create hole here, here. And then this I'm going to make a 1/4 inch hole. Oh, sorry, that's the depth. Quarter inch hole. It doesn't really matter the depth, it's just got to go all the way through. Okay, so that's where the 2 bolts are going to go to attach on our plate. And if that's the case, our plate can only be the plate can only be 2.5 inches wide, and also we were worried about it hitting the bearings. So with these bearings on top, I mean, we can put a little bit of a spacer here so it clears those bearings, which I'd probably say is ideal. probably put a spacer here, like a nylon or some sort of anti-vibrations spacer here, so none of the vibrations that are transferred through here hits that. So maybe a piece of cork or something on here, a piece of big, thick piece of cork that's really loose, and we tighten down with a little bit of tension. We will get some inaccuracies, but it will get rid of a lot of the vibration that's transferred through the machine to the head to cause the head to vibrate. Because the head being very long, any sort of vibrations as it goes down that head is going to cause it to swing quite a bit. Because that head's going to be, 6-7 inches long. So we're going to have these 2 bolts, and then there's going to be a plate over this that's obviously have to be smaller than 2 inches. 2 point something or 2.5. Has to be smaller than 2.5 inches. Space it off with a big piece of cork here so we can get it to clear those bearings, preferably, and then have it come down. Obviously not too much where we're adding a large moment where this has got a lot of weight here and it wants to rip this carriage off because we have nothing on the bottom holding it down. The only thing that's holding it down at this point is the weight of that piece. So we can't have too much weight on this guy because we need to hold it down. And everything that's going to hold it down, the belt's going to hold it down. The belt's going to be under tension, basically holding it down to the piece of steel itself, to the steel beam. Okay. So we got that. This is ready to go. Let's go ahead and save this. And then this guy, let me see if I could change it. So this is the carriage Y subassembly. Buddies. Kind of like there. Remove appearance override. Okay. Let me see if I could. I can't. Oh, here's opacity control. That's what I was looking for. Opacity controls. Okay. So that's good. That's how we want it. But we need the holes. And, because this is a body, I should be able to just drill those holes anyways. Should be able to, theoretically speaking. So let's just do that again. Oh, I don't think I did center on this one. What the heck? Oh, this is in feet. Make sure these are both vertical. I see that one wasn't perfect. Okay. Now create holes. Okay, so it is going to let me cut, so that's perfect. Alright. It's perfect. 2 inches is not a lot though. That's okay. Yeah, so that's good. So let's go ahead and save this. Okay, let's go back to our main assembly. And let's go ahead and pop up our subassembly. This should be our carriage Y subassembly. Go ahead and place that bad boy in here. Looking in the bottom, yep. Okay, so let's try to joint it. Continue on here. Perfect. Okay. I think it's something like that somewhere. Okay, it's looking close. Oh, what the heck? Okay, that's great, but it's rotated the wrong way. I mean, it doesn't really matter, but it's rotated the wrong way. Because, I mean, it's the same thing, but... Let's just rotate it. There we go. Okay, that's good. Also, I need to edit this that it is a slider that needs to go on the Y direction. And then go ahead and edit joint limits, minimum maximum. This one is only 2 feet positive minimum, and it's going the wrong way. It's negative 4 feet that way. Perfect. Okay, so now that is attached. So now if we go into the joints, we can drive this joint. This is Y gantry. This is X gantry. Drive the joint. Beautiful. Okay, so that's in there. So now we have to add the opportunity to add that plate and figure out what size that plate needs to be for the gantry itself, for the Z. Okay, so let's go here. Let's create a new one. And this one is going to be a 2.5 by 2.5. A36 plate. 2.5. Okay. No, this is 2.5 inches. Okay, this one is gonna be like 6, 5, 6, 5, 5, maybe. I have to think about that. We'll have to see when I mount it, and then we could go from there. Okay, and this is probably going to be something like 1/4 inch. And then we're going to go ahead and drill some holes. Or this could be welded, technically. It's probably easier than taking it to the mill and drilling holes. Worst case scenario is slotting and drilling holes in the mill for this particular project, because we do not have a CNC mill available. Okay, this is going to be the Z gantry plate. Let's go ahead and drag and drop that bad boy in there. Take the joints out. So let's see what's kind of thing we need. Yeah, that's small. It has to go all the way down to the table pretty much, because for starting out we're probably going to use pistol grip cutter, and the pistol grip cutter is not going to give you any extra length, so it has to pretty much go all the way down. So that means this is probably going to have to be a foot long. Oh, I only did 5 inches. Another problem that I'm seeing is that this plate is going to have to be under this space here, otherwise you're going to hit. So these ribs are going to have to be like down here somewhere. Well, technically you don't have to worry about this thing hitting. You just have to not be very close to it. Okay, so there's the plate now. What are we looking at? How tall is it above? I mean, that looks pretty good. Okay, so now that we have that, we'll have to figure out what size that actually is. But yeah, so we got that. So now we need the V-groove bearings. So let's see if we have some. Let's go to Inventables. V-wheel kit. It comprises of 2 bearings, 1 precision shim washer, and 1 V-wheel. This is a double bearing Delrin V-wheel. It uses 2 8 by whatever bearings that are afraid they'll run out. So here's a technical drawing. So this guy, technically, I mean, we could machine this with like a V-bit, really small V-bit, like 1/4 inch V-bit. Quarter inch V-bit. So here's the technical drawing of this Delrin wheel. This is a 90 degree taper here, which means 45 this way, 45 that way. So this is technically 45 degrees, and it's got a little inside there, 0.55 centered. So if this is from Instructables, by the way. How much is this? These are $5 a piece. Yeah, kind of something like that. Decent sized 3D printer. Anyways, so this is kind of the carriage plate thing that would be going on. Okay. You can see the breakdown here. Dual bearing wheel, Delrin. Very low. But I do like this. This goes up to 0.2. All dimensions in millimeters. Acetyl copolymer, which is Delrin. Okay. So yeah, this is okay. So here it is, 4.5 millimeters. So yeah, 4.5 millimeters is not a lot. Let's go ahead and do that drawing for the V wheel. Say this is V wheel. Okay, so let's go ahead and draw this, and we're just gonna put a. This has a. Did I delete it? This has a. What size hole does the bearing have? Bearing has an 8mm hole. 5 by 16 by 5, so a 5mm hole. Okay, so let's go ahead and draw a circle. Let's do. Actually, let's do a. Let's do on the front. Let's do a revolve. So first, 8mm hole. 5mm. Oops. 5mm. This is also 5mm, obviously. Okay, so that's the first set. Then we need the V wheel itself, which goes up as a total of 23.5 millimeters. So from here out, this is 23.5 divided by 2. 23.5 divided by 2 millimeters. Okay, then this is it should be 0.2. So it says here 0.45. So we have the entire thing 7.5 divided by minus 4.5. It says it's 1.5 millimeters. I don't think so. Yeah. .5 millimeters from there to there, minus. Oh, and then also divided by 2 again. No, it would be divided by 2. It wouldn't be divided by 2. Okay, let's do this. Okay, let's make this construction line. So this is 4.25. 2 point. There you go. Yeah, so there's the edge. 2.25. So there's the edge. So this is the edge here. That's the edge. And that's the edge. And then this goes down 45 degrees until the 0.55. There we go. Okay, then you go from here down to here, and from here up to there. Something, it's kind of like that, sort of. Except for this guy goes straight like a little bit. Anyways, then we need the correct angle, which is from here to here is 90 plus 45. This one's here to here. This is exactly 45. And both of these have got to be there we go. Okay, create, revolve, boom. Axis, boom. And that is a V wheel. Sort of. It's sort of the V wheel. Okay, I like it. There should be a 5mm hole right here. Let's change this to millimeters. Should have done that from the start. It looks like a pretty big 5mm. Diameter is 10. Whoopsies. Holy crap. Let's go in here. Where's the trim? Whatever, doesn't really matter. There we go. 5mm diameter, and then this should be 23.5mm diameter, which is correct. Alright, good. We have a few minutes. Let's go ahead and add these to the main assembly. Let's have this in the subassembly. Let's create this in the subassembly and then update it. Because that should actually be how we do it instead of doing it in here. So yeah, let's do that in here instead of how we're doing it there. Okay, cool. Then we need the V wheels. 1, 2, 3, 4. That scared me. I'm gonna save. Let's save everything. Oops. Don't need to. What? Oh man. Supposed to be in the carriage assembly. Not that one. Okay, let's try this again. Okay, 1. 2, 3, 4. Now obviously this is not how we're gonna do it because I'm just gonna anchor one of these on here and see what it looks like. So I'm going to anchor this. I'm going to anchor it at the center point, probably. Yeah, obviously that piece is way too big, as we talked about. That piece needs to be literally like a lot smaller than it is. And this is definitely going to hit these other pieces. So, a few things to think about in the meantime. So that's going to be it for this video. This has been Steven from Legit Tech Tutorials. I thank you guys for watching. If you like this video, please subscribe for more videos like in this series or series as well. I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.